Okay, get this. By 2060, Mars. It won't just be some remote research outpost, scientists and glorified campers. No, the forecasts we've been digging into, they project a full-on city. Maybe up to 40,000 people. I mean, that's bigger than a lot of actual cities here on Earth, never mind small towns.
Yeah, and what's really striking is this isn't just like wishful thinking. It's a detailed plan, phased, budgeted, frankly, kind of terrifyingly ambitious.
Mm.
We're basically mapping out the whole thing from, the first blueprint in the early 2030s all the way to the first Martian school opening up. And yeah, even the first sort of suburban rail lines connecting settlements across the dust.
Right. So our mission today, it's pretty straightforward. We're unpacking this blueprint, this whole idea of building a Martian civilization. We're tracking how Mars goes from being this super high-risk destination to a permanent society with geopolitics and everything. And you listening, you're about to get the roadmap that really only futurists and space architects are looking at right now.
And crucially, we're also going to lay out those four make-or-break scenarios, the catastrophic what-ifs that could just stop this whole 40,000-person dream cold. That's the really high-stakes part we need to face.
Okay, let's dive in. The timeline. It's laid out in three main phases. Phase 1, that's roughly 2025 to 2035. They're calling it the exploration phase.
Yeah, and this part, it's all about survival. Purely survival, not really settlement yet. The goal is just establishing that first foothold. Key actions are the first crewed landings. We think that's likely early next decade, around 2030, 2032 maybe. And then quickly setting up Mars Base Alpha. We're talking maybe 50, perhaps up to 200 initial pioneers, high-risk pioneers.
And the tech they need? Wow. It's dense. You've got robotic precursors landing first, right? Getting the initial ISRU, that's in situ resource utilization, up and running. That's the whole living off the land thing, turning Martian dirt and ice into supplies, plus installing the first nuclear reactors for power. And getting those first hydroponic farms going. I mean, without power and food.
It's dead on arrival. Exactly. And that immediately brings up this really tough question the sources highlight. Given the risk, I mean, it's almost unimaginable who are these first Martians. They're not just scientists popping over for a field trip. These are people who know the mortality risk is off the charts, higher than anything before. We're talking about people accepting potentially permanent separation, maybe even knowing they might not survive.
That foundation is built on just pure nerve. Okay, so if phase 1 is survival, phase 2, the settlement phase, 2035 to 2050, that's where things really scale up, right? We stop thinking small.
Oh yeah, the numbers just explode here. You jump from that initial couple hundred up to over 2,000 colonists. And this is all down to logistics, huge logistical shifts.
Sure.
We're talking second, third waves of people arriving on these big mass transport ships. Think SpaceX starships, packing maybe 500 plus passengers for each trip.
Wow, 500 people at a time. Just trying to wrap your head around that. It's I don't know, trying to load an entire village from, say, rural Italy, or maybe a whole apartment complex from Bangalore onto one single flight, and then doing it again and again every couple of years when the planets align. The margin for error on life support, food, everything, it's basically zero.
Absolutely zero. And what you see happening almost immediately as the population grows, so does the politics, the geopolitics. The data suggests that right around this time, international competition really starts to formalize. We expect to see China establishing its own independent research station on Mars. And, this is interesting, Blue Origin starting operations, but focused on Phobos.
Phobos. Okay, quick reminder for everyone. That's one of Mars's little moons, right? The lumpy one. Why Phobos? Why not just stick to the surface with everyone else? What's the strategic advantage there?
Phobos is potentially the ultimate orbital gas station and staging post. It's got incredibly low gravity. So, launching resources from Phobos, maybe back to Earth, maybe for construction in orbit, maybe refueling ships, it takes way less energy than lifting off from Mars itself. Getting stuff out of Mars's deep gravity well is hard. Phobos makes it easier, signals that shift from just exploring to actually starting to use resources.
Okay, so by 2050, it's not just one big happy family at Base Alpha. It's a competitive landscape, different nations, private companies. And within all that, we hit some huge societal milestones. The first babies born on Mars. I mean, think about the biological and ethical questions there. And the first Martian school opening up, maybe around 2048. Civilization is literally taking root, which means you need bigger infrastructure.
And that leap, that whole transition, it's really only possible because of a massive technological jump. Fusion power. We're talking fusion-powered spacecraft, yes, but maybe even more critical, fusion power plants on Mars.
Ah, the infrastructure revolution. Let's unpack that because, well, the sources seem pretty bullish on fusion by 2050. That feels optimistic. We start with nuclear fission, those initial reactors. Why is fusion the absolute must-have to get past, say, 2,000 people?
It changes two fundamental things. First, speed. Right now, getting to Mars takes, what, 6 to 9 months?
Hmm.
Fusion propulsion could potentially cut that down to 3 or 4 months. That makes regular supply runs much more feasible,
Hmm.
reduces the psychological toll, too.
Hmm.
But second, and this is the big one for that 40,000-person city vision, fusion provides the sheer amount of continuous power you need to run a large-scale settlement.
Right, a city of 40,000,
Yeah.
you need constant power for massive oxygen generation, climate control in huge domes, transport systems, 24/7 manufacturing. Fission just can't scale like that.
Exactly. And that kind of sustained civilization, it needs three core technologies working perfectly on the ground. One, massive scale water extraction, pulling it from that subsurface ice. Two, equally massive oxygen production using ISRU, pulling it from the atmosphere and rocks. And three, you absolutely need reliable, large-scale 3D printing and manufacturing. If a critical part breaks a habitat seal, a rover component, you can't wait 6 months for a replacement from Earth. You have to make it there.
Okay, so faster rockets, making your own air and water, printing your own parts. But there's still one huge bottleneck, isn't there? One thing that the sources say really fundamentally separates Mars from Earth, almost forces independence, the latency problem.
Yes, and what's so fascinating here is how a technical constraint basically dictates the political future. How do you run a city, let alone coordinate multiple settlements, when the communication delay is anywhere from 7 to 24 minutes each way?
Hmm.
Send a question, the absolute fastest you can possibly get an answer back is 14 minutes, often much longer.
Imagine trying to handle an emergency, like a fire in a habitat, or a complex trade negotiation between settlements, or even just managing daily operations. Every single back and forth takes minimum a quarter an hour, maybe closer to 45 minutes. Earth cannot micromanage Mars like that. It's impossible.
So that lag, it's more than just an annoyance, isn't it? It's effectively a declaration of operational independence baked into the physics of the solar
It
system.
really is. The sources are pretty clear. Autonomy is forced on them way before they might vote for it. Mission control on Earth has to shift. They can set goals, provide resources, but the day-to-day decisions, the real-time execution, that has to be Martian. And that forced autonomy, it really sets the stage for the final phase, the civilization phase, from 2050 to 2060.
Right, and this is where we hit that headline number.
Yep.
That jump from maybe 7,000 people up to the projected 40,000, maybe even more. This isn't just a base or a settlement anymore. This is described as Mars City, a multi-district urban sprawl.
Okay, paint a picture for us. What does a 40,000-person city look like under a dome, or maybe multiple domes?
Yeah, they get interconnected, sprawling, domed areas. Not one giant bubble, probably, but multiple linked hubs. Residential districts, industrial zones, research labs, and connecting them, pressurized suburban rail networks. Trams or trains running in tubes or tunnels. The big challenge there isn't so much building the rail, it's maintaining everything against that fine, corrosive Martian dust and the constant pressure differences. And this level of complexity, this scale, is probably why we see the emergence of multiple independent settlements, and potentially competing ones. American, Chinese, European, private, all figuring out how to coexist and share, or maybe not share, resources.
And governance. Wow, that becomes incredibly tricky. You've got separate settlements, maybe with different rules. You've got that forced autonomy from the time lag. And now you have a whole new population growing up there. The first generation born on Mars, raised under artificial lights and lower gravity, kids who've never known Earth.
They are the real separation point, aren't they? They'll develop their own culture, their own norms, a different relationship with risk, maybe even slight physiological differences over time. Which brings us right to those critical pivot points. That hidden bonus, if you like, rewarding you for sticking with us through the plan. Because the projections, they're brutally honest about 4 potential showstoppers, 4 things that could make this whole dream collapse even after the city starts growing.
This is the dose of reality, then. What are these 4 potential catastrophic failures?
Okay, the first one is political and financial, right at the start. What if that very first crewed landing fails catastrophically? We're not just talking a delay. We mean a total loss, a Challenger or Columbia-level disaster, but on Mars. The political fallout, the cost. It could set back human Mars missions by decades, maybe 50 years. Too big a blow for anyone to recover from quickly.
That just stops everything before it starts. Okay, what's the biggest physical threat once they're actually there, once base alpha is running?
That would have to be long-term radiation exposure. What if, after say 10, 15 years of people living there, even shielded under dirt? What if the cumulative dose of galactic cosmic rays and solar radiation turns out to be much worse than models predict? Not just slightly higher cancer risk, but serious widespread health crises. neurological damage, fertility problems, a biological barrier that makes long-term settlement impossible for Earth-born humans, forcing an abandonment.
A biological dead end. Okay, that's two. What are the other critical threats to this 40,000-person city?
Third, the biology of reproduction itself. What if, simply put, humans can't reliably or sustainably reproduce in Martian gravity and conditions? We just don't know the long-term effects of 38% Earth gravity on conception, gestation, fetal development. If you can't successfully raise the next generation on Mars, then the whole settlement eventually just ages out. It depends forever on immigration from Earth.
A slow-motion extinction for the colony. And the final one. Is it resources?
It's exactly resource scarcity. What if the surveys are wrong? What if the easily accessible water ice isn't as widespread as we hope? Or what if some other crucial element needed for ISRU for making fuel or plastic or metals turns out to be rare or hard to extract? If the local Martian supply chain can't support 40,000 people, Earth's supply chain definitely can't make up the difference. Not sustainably. That forces abandonment too.
Wow. Okay, so looking back then, we've gone from this tiny high-risk outpost in the 2030s running on fission, through this massive population boom enabled by fusion power and huge ships, all the way to a complex, multipolar, rail-connected metropolis of 40,000 by 2060, on the brink of real independence.
And the connecting thread through all of that, the real core insight. It isn't actually the technology. Tech gets you there, tech keeps you alive, sure. But the civilization part, that's driven by overcoming that 7 to 24-minute communication gap. That gap, that enforced isolation, is the catalyst. It forces the rise of a separate Martian identity culturally, politically. The delay defines the destiny, almost.
Which leads us to that final, really provocative thought, building right on what the sources suggest. If you have multiple competing settlements, everyone operating with this huge time lag from Earth, will those kids who grew up Martian, never feeling full Earth gravity, never seeing a blue sky with clouds, will they even consider themselves fully human in the way we understand it? Or are they fundamentally the beginning of something new, a post-human branch?
That's the question that starts becoming very real around 2048, isn't it, when that first school opens its doors?
Well, thank you for joining us on this deep dive into the blueprint for Mars City 2060. Really fascinating stuff. And remember, every insight gets deeper on the second listen, so make sure you save this deep dive in your library.
Yeah, we've covered the timeline, the tech, the potential disasters. But next time, we need to get into the really thorny stuff. The cost of citizenship. What does political separation actually look like? Are Martians colonists under Earth law? Or are they a new nation? That's where we're going. Don't miss it.